we continue with the next presenters, Ms. Lovna, yeah, on comparative study of date palm midrib and Spadix fibers with other leaf fibers and their composites. Okay, welcome, Lovna. Start your presentation.
Hello, everyone. Thank you, Professor Aida. Thank you for all the organization committee. I will share my screen now. Okay. I'm Lubna Saifi, lecturer assistant and PhD student at the German University in Cairo. Today, I will be presenting our work titled Comparative Study of Date Palm, Midrib and Spadix Fibers with Other Leaf Fibers and Their Composites. Okay, yes, okay. Many researchers are now working with date palm fibers, and many researchers are claiming that date palm fibers are good. But how good is good? To what extent are date palm fibers considered comparable with the other natural fibers? And if we want to compare these fibers with other natural fibers, to which family would we compare it to? Bast fibers, to leaf fibers, to fruit fibers? Some attempts were made in the literature to compare the date palm fibers to other work also found in the literature, but will this comparison be considered fair? Changing any of the conditions or the factors in the testing would affect definitely the results of this test. So our main objective is to compare date palm fibers, specifically midribs and Spadix stem fibers, to other leaf fiber, the same family of the date palm, like sisal, abaca, and pineapple and banana fibers, to determine and benchmark the date palm fibers. So starting with the fibers characterization. In this work, 3 types of date palm fibers were extracted, midribs and Spadix stem, and from the midribs we extracted 2 different fibers, the core and skin fibers. And as mentioned earlier, we compared the date palm midrib core fibers, the date palm midrib skin fibers, and the date palm Spadix stem fibers to other 3 leaf natural fibers, sisal, manila hemp, which is sometimes referred to also as abaca, and banana fibers. And we specifically chose those 3 fibers due to the visual similarity between them. When inspected, the sisal fibers looks like the date palm midrib core fibers, and also the manila hemp is similar to the date palm midrib skin fibers, and the banana fibers are similar to the Spadix fibers. For fibers characterization, we calculated the cross-sectional area of the fibers. We also determined their chemical properties by measuring the weight percentage of cellulose, hemicellulose, and lignin. And we are planning to do a scanning electron microscope analysis to determine the cross-section and the longitudinal views of the fiber. For the mechanical properties, we performed X-ray diffraction, and we are still working on the single fiber tensile test. Finally, for the thermal properties, thermogravimetric analysis was made. Starting with the chemical composition result, it was found that manila hemp had the highest cellulose weight percentage compared to the other leaf fibers in this study, followed by date palm, Spadix, and the banana, and then the date palm midrib fibers and sisal. Here we can see that the weight percentage of cellulose in date palm fibers, either the midrib or the Spadix stem, is comparable with the commonly used leaf fibers like the sisal and the manila hemp. As for the cross-sectional area analysis, we found that the smallest cross-sectional area was for the date palm midrib core fibers and the banana fibers, followed by the date palm Spadix stem fibers. We also found that the date palm midrib skin fibers had the highest area values, and this could be due to the large amount of impurities found on the surface of the fibers, which may make it somehow difficult for the penetration of the caustic soda, and we are going to further investigate this point. Also, it's commonly assumed in the literature that the cross-sectional shape of the fibers is round and circular. So the cross-section area is miscalculated. In this work, we measure the cross-sectional area using the Court method, and we trace the cross-sectional area using an optical microscope software. These are scanning electron micrographs of sisal, manila hemp, banana, spadix stem, and midrib fibers. And somehow the sisal and manila hemp have similar cross sections. However, the date palm midrib fibers is not quite similar to their cross section. It has lumens inside the vascular bundles. As for the results of the XRD, the crystallinity index and percent crystallinity in the 6 types of fibers was calculated, and it was found that sisal and midrib skin fibers had the highest crystallinity index and hence the highest percent crystallinity, followed by the manila hemp, banana, and spadix stem fibers. The crystallinity index gives or indicates the amount of cellulose present in the material, and as the crystallinity index increases, it indicates dominance of the cellulose element, which is the load-bearing element, and hence give insight on the mechanical properties of the fibers. For the thermal properties, TGA, 6 TGA graphs along with the DTG graphs are present in this slide. The 6 types of fibers had 4 thermal decomposition stages. The first stage corresponds to the dehydration, followed by the decomposition of hemicellulose, then the decomposition of cellulose, and finally the composition of the lignin. And it was found that nearly all the fibers were thermally stable up to 250 degrees Celsius. Moving on to the composite manufacturing and characterization, 50% polypropylene in fiber form was blended with 50% natural fiber, and specifically this weight percentage was chosen since this is the most commonly weight percentage used in the automotive industry that renders high mechanical properties, lightweight, and better or good acoustic properties. These fibers were blended together to give this polypropylene natural fiber blend. And then this blend or this dry non-woven mats were put into or were hot pressed. Following these 4 stages, first oven drying, followed by preheating, hot pressing, then cooling of the composite. Afterwards, the sample was cut to have tensile, bending, and impact specimens according to the ASTM standards. So these are the 6 forms of the composites, showing the different visual appearance of sisal, manila hemp, and hence all the fibers. Moving on to the tensile properties of the composites, it was found that manila hemp composite had the highest tensile strength compared to the other fibers, followed by date palm spadix, date palm midrib, and the sisal fibers. They were all within the same range, and there was no significant difference between their values. And finally, the banana fibers. This diagram shows the modulus of elasticity shown with blue bars and the strain at break in green bars. The modulus of elasticity followed the same trend of the tensile strength. However, we noticed that the strain at break of the sisal and the manila hemp were, and also the date palm spadix were higher than the other 3 fibers, and this indicates high toughness of the fibers or the composites. Moving on to the flexural properties. On the left is the stress strain diagram, and on the right is the bending strength, showing that the manila hemp and sisal fibers and even the date palm fibers are all within the same range. There is no significant difference between their values, and the 5 fibers were followed by the banana tensile strength. When we compared the date palm midrib, either core skin, to the date palm spadix composite, we found that the bending strength of the date palm spadix is somehow lower than the other values, and this could be because date palm spadix is composed of pure fiber bundles, so it's flexible, which makes its bending strength much lower. So for the composite dynasty, the thick samples were within the same range with a slight increase in the date palm values. Moving on to the applications of these composites, the date palm composites could be used in the automotive industry, either in external or internal applications. Also, they could be used in packaging and in construction and building. Moving on to the conclusion. Date palm fibers are textile fibers that have comparable properties to well-known vegetable fibers, specifically the leaf fibers. Date palm fibers or spadix stem fibers have accepted properties that will allow them to be used in various applications, just like the commonly used fibers. And we are proud to introduce this new class of fibers to the library of natural fibers. Also, I believe that in the near future, date palm fibers will be commercially available, and I'm also sure that in the future, any fiber classification will include date palm fibers. We are also intending to continue our further characterization to determine the tensile strength of the fibers, to do the SEM, and to determine the impact properties, water absorption, moisture content for the composites. Thank you so much for your attention.
Thank you very much, Ms. Lobna, for the presentation. Ms. Lobna, just now the matrix for the composite is polypropylene. Is it in polypropylene?
Yes.
Polypropylene,
yes.
in the form of like foam, like what?
In the form of thin fibers, or
thin fibers. Okay.
Yes.
In the form of thin fibers. That's why it can absorb very well with the natural fiber. Yeah.
Yes, the natural fiber. The 6 samples were cut into the same length as the polypropylene. Okay. And they were blended together so as there will not be any resin spots.
And compressed using the hot press, right?
Yes.
How about the fiber volume fraction?
Again, please.
How about the fiber volume fraction, roughly for all types of all types of composite?
We didn't measure the volume fraction. However, we know the weight fraction.
Okay. Okay. I would like to open the question for all participants. Is there any question? Raise your hand. Oh, Professor Kais. Let's answer. Unmute, Prof. Kais.
Thank you very much. Thank you very much for Ms. Lubna for the quality of the presentation. I have some response for my question to Dr. Midani for this comparison. My question is, can we correlate it in we want to predict the mechanical behavior by the modeling, correlated between the morphology as the cross section for each kind of fiber and the mechanical property? Did you have an idea about this?
I'm sorry, can you repeat the question again? You are asking about a correlation between the morphology of the fibers?
Yes, Professor Kais is actually asking about like the relation between the microstructure and the morphology of the fibers and the fiber performance. Did you study this?
We are studying this point, and this point is still under investigation, but we believe that there is a relationship between the cross-section of the fiber and its structure and its other properties, yes.
I think that in this project we can collaborate, and I think we will have the discussion between you and Professor Midani to collaborate, yes, because we work on the modeling.
Thank you, Prof. Kais. And the cross-section area, the microstructure of the fiber, you can relate the microstructure and cross-section to the fiber volume fraction, actually. Yeah, Ms. Lofna? Okay. Prof. Basim, do you have any question? Unmute, Professor.
Yeah. Thank you, Ms. Lubna, for this presentation. Actually, I have many questions, but I will, due to the limited time. Now, we know that here for the date palm trees, we have different types, and it is not only one type.
Yes.
We have 5, 6, maybe more. It depends on the countries. Okay. Khalas, Sukkari, etc. Okay. Now, which one you have selected? And do you think that there is no difference between these in terms of the properties you have tested?
Yes, we know the species of the date palm, and they were all from the same tree. But excuse me, I just forgot the species.
Hayani.
Yes, Hayani.
But we did also previously we worked on like a female barhi date palm, but this work is on Hayani, female Hayani palm.
Good. Another question. Now for the XRD, we have 2 peaks.
Okay.
For what these 2 peaks?
The 2 peaks corresponds to the amorphous and the crystalline peaks, usually at 2 theta equals 16 and 22 degrees respectively.
Okay, now the highest one is for the cellulose, for the crystalline, right?
Yes.
Okay. Okay, thank you, Ms.
You're welcome.
Thank you, Prof. Basim. Is there any question? Any other question from the floor? Prof. Hamid, do you have any? Unmute, Prof. Hamid.
Please
not hear you. Unmute, Prof. Hamid. Okay, yes. Okay. We hear you.
You hear me?
Yes.
You hear me?
Yes.
I have a comment and a question. I think that first I thank thank you very much for Lubna for your excellent presentation.
Thank you.
I just have a comment and a question. A comment is as follows: why wouldn't we rationalize our research work? I mean that if we compare between the palm midrib and the Spadix stem, the palm midrib has many uses in many traditional arts, for example, making crates. But the Spadix stem is totally neglected and totally used as treated as a waste. So I should take care more of the Spadix stem than the midrib. The second remark is that you worked about the Hayani, but I think that the seaweed species is much more dominant in Egypt. For example, in New Valley and in El Bahariya and in many other places. So why wouldn't we work on the most dominant species of the palms? The third is a question, not a comment. I would say that Spadix stem is better than the palm midrib. Why? Because on the periphery you have pure fiber bundles, not fibrovascular bundles. So it is easier to extract pure fibers from the Spadix stem than the midrib. I have a question to you. Have you any idea about working on the leaf sheath? The leaf sheath are, as you said, are pure fiber bundles, and they are almost totally burned or treated as waste in Egypt, for example. In my field work, I was able to extract from each leaf a whole textile of the fibers. The width is the length of the petiole, and the length is the perimeter of the palm. I mean, if you properly prune a palm tree, you can get woven pieces of a very regular size of pulp sheets. Don't you have any plan for this in the future?
Yes, date palm has many sources of fibers, and it would be interesting to investigate all the different types. And I agree with what you said. For your question about why we chose this cultivar, yes, it makes sense to use the most commonly cultivar available in Egypt. But we try to investigate different cultivar to check if there is a difference. Our previous work was about the barhi, so now we are investigating another cultivar.
This could be also a good
Thank
opportunity for a new research that investigates the mechanical and properties of different cultivars from different sources. In this session, later today, we will have different speakers who will present their work on the date palm sheath fibers and their composites. So we have Saeed Awad from University of Brunel in UK. He done a very good work in this context.
Okay, thank you very much, Dr. Midani, Ms. Lofna, and also Professor